Hello, everyone. What is the system? Our project is called the Smart Diet and Meal Planning System. It's an AI-powered mobile application designed to help people maintain healthier eating habits in a more organized and personalized way. Nowadays, many people struggle to eat healthy because of busy schedules, lack of time, or insufficient knowledge about nutrition. Our system aims to solve this problem by offering personalized meal plans according to users' health goals, calorie needs, and food preferences. In addition, the system also helps users track their calorie intake, receive AI-based meal suggestions, and automatically generates grocery shopping lists, making healthy eating easier and more practical. Purpose of the system. The main purpose of our system is to support individual in achieving healthier lifestyle. Through personalized nutrition planning, many people find it difficult to follow up a proper diet due to busy daily routines, lack of planning, or difficulty maintaining motivation. Therefore, our system aims to simplify the diet planning process by giving users meal suggestions that match their personal goals and dietary needs. For example, users who want to lose weight, gain muscle, or simply maintain healthy eating habits can receive customized recommendation. Another important purpose of the system is to save time by automatically creating grocery lists and meal plans. Next one, who will use the system? Our system is designed for a wide variety of users with different lifestyles and nutritional goals. First, it can be used by health conscious individuals who want to improve their eating habits and maintain balanced nutrition. Second, beauty professionals and university students who do not have enough time for meal planning can benefit from quick and personalized meal suggestions. The system is also suitable for fitness-focused users who want to lose weight, gain muscle, or maintain their body goals. In addition, people with dietary restrictions such as vegan, vegetarian, gluten-free, or allergy-sensitive diets can use the applications to receive personalized meal recommendation. Next one is what does the system do? The system offers several important functions to support health and nutrition management. Users first create a personal profile by entering information such as age, height, weight, dietary preferences, allergies, and personal health goals. Based on this information, the system provides personalized meal recommendation using artificial intelligence. Users can also track their daily calorie intake and monitor their nutrition habits over time. Additionally, the system automatically generates a grocery shopping list according to selected meals, making meal preparation easier and more organized. Overall, the application works as a smart nutrition assistant that combines diet planning, calorie management, and healthy lifestyle supports in one platform.
On this slide, I will explain the system requirements of Smart Diet and Meal Planning System. The main purpose of the system is to help users maintain healthy eating habits through personalized nutrition support. There are two types of requirements. First, the functional requirements. These include user registration and login, profile management, diet goal selection, calorie tracking, AI-based meal recommendations, meal plan generation, grocery list creation, and progress monitoring. The second one is the non-functional requirements. The system should be secure, easy to use, accessible from both mobile and web devices, and provide best performance for users. We can continue. This slide presents the main use cases and shows how the system works step by step. Firstly, users create an account and log into the application. Then they enter the personal information such as age, weight, height, and dietary preferences. After that, users select a nutrition goal, for example, weight loss, muscle gain, or weight maintenance. Based on this information, the system calculates calorie requirements and provides AI-generated meal recommendations. Users can create daily or weekly meal plans, and the system automatically generates a grocery list. Finally, users can track their calorie intake and monitor their progress over time. And the application screen on the left demonstrates how these features would appear in the actual mobile application. We can continue. And this slide shows the interactions between users, administrations, and the smart diet and meal planning system. The user is the primary actor of the system and can perform activities such as registering, managing their profile, setting diet goals, and tracking calories, receiving meal recommendations, generating meal plans, creating grocery lists, and viewing progress reports. The administrator has fewer responsibilities and mainly manages the food database, updates meal information, and maintain user records. Overall, this diagram helps us understand how different users interact with the system and how the system supports personalized nutrition management.
What you see here is the system's class diagram. The system is built upon 6 main classes: user, meal plan, shopping list, AI recommendation, and daily calorie log. Each box represents an entity. The top section shows the name of the class, and below it are the data held by that class. In other words, its attributes. And the arrows between the boxes indicate the relationship between the classes, which I will get into in a moment. And now let me briefly summarize each class one by one. The user class holds the user's account and profile information, such as name, age, height, weight, and diet goal. The meal class stores the nutritional values of the meals: calories, protein, carbohydrates, fat, and meal type. Meal plan stores the daily plan generated for the user, containing the dates, target calories, and the total calories. Shopping list holds the grocery list generated from the meal plan. AI recommendation stores the meals suggested by the AI, along with the reason for the recommendation. Finally, daily calorie log records the meals the user actually consumed during the day and the total calories. In short, each class summarizes the data of a specific entity in the system. The relationships between the classes are predominantly one-to-many. A user can have multiple meal plans, shopping lists, AI recommendations, and calorie logs. However, each of these records belongs to a single user. Similarly, a single meal can appear in multiple daily calorie log records. Daily calorie log is a special class. It connects to both the user and the meal because it tracks which user ate which meal information. In the diagram, the one represents a single record while the asterisk represents multiple records. These relationships are established in the database using primary and foreign keys.
Database design. We selected MySQL as our database because it's reliable and suitable for storing structured data. The database stores user profiles, meal information, meal plans, calorie records, shopping lists, and AI recommendations. These tables are connected through relationships. For example, one user can have multiple meal plans, calorie records, and shopping lists. This structure keeps the data organized and makes the system easier to manage. On the right, you can see the relationships between the tables. We can continue. Our system uses Flutter for mobile application, Node.js for the backend, and MySQL for database management. We also use the OpenAI API to provide personalized meal recommendations. User login is handled through an email and password system, while cloud hosting supports the application and database servers. On the hardware side, users only need a smartphone, tablet, or computer internet connection. On the server side, the system requires a web server and a database server. As shown in the diagram on the right, the user interacts with the Reader application, which communicates with the Node.js server, the MySQL database, and finally the OpenAI API. We can continue.
And the last one, implementation plan. To develop our smart diet and meal planning system, we created a structured implementation plan consisting of 7 phases. First, we would conduct a requirements analysis to identify user needs and define the system requirements. Next, we will design the overall system architecture, including use case diagrams, database structure, and user interface layouts. After that, we will develop the database and create the AI recommendation model responsible for generating personalized meal suggestions. In the following phase, we will build a prototype to demonstrate how the application works. Once the prototype is completed, the system will be tested to evaluate functionality, usability, and recommendation accuracy. Finally, necessary improvements will be made based on testing results and user feedback. This step-by-step approach ensures an organized and efficient development process. Thank you for listening.